You know, when you picture the Sydney skyline, your mind might jump to the Opera House. But there's another shape that truly dominates the view, this massive, powerful curve of steel. This is the story of that incredible structure, the Sydney Harbour Bridge, and the absolutely mind-blowing engineering that went into it.
Yeah, the locals have this great nickname for it, the coat hanger, and you can totally see why. But don't let that cozy name fool you for a second. This thing is a 52,000-ton giant, and it was built during the Great Depression. The fact that they pulled this off during such a tough time makes it even more remarkable.
So that just begs the question, right? How on earth did they build this thing? I mean, we are talking about a time with basically no safety harnesses. You had guys just balancing on steel beams hundreds of feet in the air. This was a project that took just as much raw courage as it did brilliant engineering. Let's start with the most fundamental choice they had to make.
So, our story really kicks off with the first and biggest decision for the engineers. When you've got a harbor this wide and this deep, what kind of bridge do you even build? Well, the answer, as it turns out, was an arch.
See, they pretty much had to rule everything else out one by one. The harbor was just way too deep to sink giant support piers into the metal. And a suspension bridge, like the Golden Gate, that was considered too wobbly, too flexible for the heavy trains they needed to run across it. So that left one design that gave them the raw, unshakable strength they were looking for, the Two-Hinged Steel Arch.
And the real genius of the design? It all comes down to one simple force: compression. So while a suspension bridge pulls on its cables, that's tension, an arch pushes all its weight outwards and downwards right into its massive foundations. What's crazy is that this means the more weight you put on it, all those cars, all those trains, the tighter the arch actually locks itself together. It literally gets stronger under pressure. Okay, hold on. If this whole thing is about rigid compressed strength, then this next part is going to sound a little weird. Why in the world would a 52,000-ton steel bridge need hinges? It almost sounds like a weakness, right? But it's actually one of its most brilliant features. Well, the answer actually goes back to something you probably remember from high school science class: thermal expansion. It's simple, really. When things get hot, they expand. When they get cold, they shrink. And a gigantic piece of steel sitting out in the hot Australian sun is definitely no exception. And we're not talking about a tiny amount here. The scale of this movement is staggering. On a really hot summer day, that massive steel arch can rise by as much as 18 centimeters. That's about 7 inches. Now, if the bridge were locked rigidly in place, that enormous pressure would eventually just crack the whole structure apart. But these hinges, they let the entire bridge rotate, just a tiny bit, allowing it to breathe with the temperature changes. So clever. So, okay, the design is genius. But now for the monumental challenge. How do you actually build a massive arch over open water with absolutely zero support from below? It's not like you can just build scaffolding across the entire Sydney Harbour. The answer was a technique called cantilever engineering. The plan was as gutsy as it gets. Build 2 half arches, one from each shore, reaching out over the water like 2 giant arms, and just hope they meet perfectly in the middle. Talk about a high-stakes plan that required unbelievable precision. And here's exactly how they pulled it off. First, to stop the 2 halves from just toppling into the harbor, each side was held back by 128 enormous steel cables. These were anchored deep inside tunnels they dug into the solid rock on shore. Then came the real heroes of the construction: 2 custom-built 580-ton cranes they called creeper cranes. These things would sit on top of the arch, build a new section out in front of themselves, and then literally creep forward onto the piece they just built to start the whole process over again. So for months, you have these 2 massive steel arms just hanging there, suspended over the harbor, inching closer and closer together. And this all led to the single most critical, most nerve-wracking moment of the entire project: the day they finally had to close that terrifying gap. All right, picture this. It's August 1930. After years of this painstaking work, the 2 halves are just inches apart. The whole city of Sydney is holding its breath, watching. This was it. This was the moment of truth. Was all that math, all that steel, and all that back-breaking labor going to pay off? Except there was a problem, a huge problem. They didn't fit.
The unbelievable tension from all those anchor cables had actually pulled the tips of the arches just slightly out of alignment. After all that work, they were just a few agonizing inches away from connecting.
The solution was just terrifyingly delicate. Imagine this. Engineers had to slowly, painstakingly loosen the tension on all 128 of those massive cables in perfect unison. They were basically lowering thousands and thousands of tons of steel into place, millimeter by millimeter, until, finally, the two halves touched and they could lock them together. The slightest mistake could have been an absolute catastrophe. Okay, so the arch is finally joined, it's supporting its own weight. Huge sigh of relief, right? Well, the job was far from over. Now they had to permanently stitch the entire steel skeleton together. And back in the 1920s, that didn't mean welding.
No, it meant rivets. And not just a few. We're talking about 6 million of them. That's right, welding technology just wasn't trusted for a load this heavy back then. Every single connection on this enormous structure is held together by a hand-installed steel rivet.
And the way they install them was like this incredibly dangerous ballet. You had a four-man team. First, the cooker would heat a rivet in a furnace till it was glowing white-hot. Then a thrower would literally toss this molten piece of metal up to 20 feet through the open air. A catcher would snag it in a little metal bucket, and then the fourth guy, the gun, had to hammer it into place with a huge pneumatic gun, all before it had a chance to cool down. An absolutely incredible and incredibly dangerous feat of teamwork.
Finally, by 1932, the bridge was complete. But before you can open it up to the public, you have to prove it's safe. And remember, they didn't have fancy computer simulations, so they were left with only one option: a test of pure, unadulterated brute force.
And how much force are we talking about? Well, they started by gathering 96 of the heaviest things they could possibly find in the entire country.
That's right, they drove 96 steam locomotives onto the bridge at the exact same time, parking them end to end, filling all 4 of its railway tracks. It was the ultimate stress test. And the result? The bridge took all of that immense weight without even flinching. It was more than ready for anything the city could throw at it. The Sydney Harbour Bridge, it really is so much more than just a way to get across the water. It's this incredible testament to what we can achieve, a powerful reminder that even in the toughest of times, we can find a way to connect what's divided. It just proves that with enough steel, enough math, and enough bravery, you really can span any gap.